Good day everyone, I am Jonathan Padayo, and my presentation is all about random sampling vis-a-vis statistical methods. This presentation is going to show the different steps in doing random sampling and its relation towards statistical methods. First, let's have sampling. Sampling is the process of selecting a subset of the population. In this subset of the population are the ones considered as the respondents of the study. In these respondents are the people to answer questions that is meant to yield data for the research study. Statistical methods. These are the procedures used in the collection, presentation, analysis, and interpretation of data. The data being mentioned here are the ones that is being collected from the respondents selected out of the population. That is why it is very imperative to see to it the appropriateness of selecting the sample. It is said that the sample or the respondents being selected must be representative towards the entire population being considered for the study. There are two kinds of sampling methods, and these are the probability sampling and the non-probability sampling. The probability sampling is considered as an unbiased sampling because the sample here is drawn and recorded by a method, whereas for the non-probability sampling, it disregards the random selection of the subject. That is why it is also known as a biased kind of sampling. For this presentation, we are going to concentrate on the probability sampling. For probability sampling, there are four types of methods. They are the simple random sampling, systematic sampling, stratified sampling, and cluster sampling. For simple random sampling, this kind of sampling assures that every member of the population has the same opportunity of being in the sample. It is a process that uses a pure chance selection. And this kind of sampling is also known as the lottery technique method. Kind of sampling, here are the steps. For step 1, define the population. For defining the population, he has to define as to whether if the population that he is considering is appropriate for the study that he is going to be doing. Step 2, choose the sample size. In choosing the sample size, the researcher cannot just simply have and choose a certain number or sample size out of this population. There are certain procedure or even formula that is being used in getting the sample size out from a population. Later in this presentation, we will know how to get the sample size out of a population. Step 3. List the population. In this step, the researcher will have or take a list of all the members or all the units of the population. He will then, in step 4, assign number to each unit. For step 5, the researcher will now be finding the random numbers. First, he could do lottery. He could put the names of the numbers in a bowl and selecting the samples randomly. Or the researcher could also use a random number generating app. The researcher could utilize it in selecting the sample that he is going to consider for the study. The researcher will do the selection until he is able to get the total number of the sample size. Next is systematic sampling. In this kind of sampling, sample members from a population are selected according to a random starting point but with a fixed periodic interval. The researcher moves through the sampling frame list and selects one out of every fixed number of entries. And here are the steps for systematic sampling. As you can see, step 1 to 4 is just the same with random sampling. However, for step 5, we have here calculate sampling interval, and there is a given formula which is I is equal to n divided by n. I here is the sampling interval, uppercase N is the population, and the lowercase n is the sample size. Step 6. Choose a random starting point from 1 to I. Step, the researcher will choose an starting point, and from there, he will be using the sampling interval generated in selecting the next sample for the study. He will be doing that until such time that the researcher will get the total number of sample he needed. Step 7. Choose subsequent element to complete the sample. Here is a video showing how systematic sampling is being done.
Let's say we have a population numbered from 1 to 30, and we desire to have 5 samples from this population. With that, we can calculate our sampling interval. Using the formula, a population of 30 divided by 5 as our desired sample size, our sampling interval is equal to 6. After which, you choose a random starting point between 1 and the sampling interval. Let us say we randomly picked 1. To obtain the final sample size in the population, you add the random starting point plus the sampling interval. In this case, 1 plus 6 is equal to 7, plus 6, 13, plus 6, 19, and plus 6, 25. The blue circled individuals are the chosen samples.
Next is stratified sampling. For this kind of sampling, it involves selecting research participants based on their membership in a particular subgroup or stratum. For this sampling, the researcher will put the population into subgroups, and each subgroups or stratum has a different characteristic or classification from the other stratum. And here are the steps for stratified sampling. Step 1 is still define the population. Step 2, choose the sample size. Step 3 is choose the relevant stratification. This is the part where the researcher will put the population into subgroups or strata. And each stratum or subgroups have a different characteristic from the other. Step 4, list the population according to the chosen stratification. Step 5, calculate the proportionate stratification. For this step, the researcher will do some calculation to get the desired number of samples from each stratum. Step 6, the researcher could use simple random or systematic sampling to select the sample from the strata. Here is a video showing how stratified sampling is done.
Imagine that you have a school of 580 students and you want to take a sample of 40. But here's the thing, you don't want to just randomly pick 40 people out of the school, you want all grades to be appropriately represented. How do you ask the right number of people in each grade? How many should you ask in each grade? Let's look at our breakdown here of this particular high school. The 580 students, 120 of them are 9th graders. 150 are 10th graders, 130 in 11th, and 180 in 12th grade. And if you add these up, we have 580 students altogether. You can see that the 9th grade is actually a little bit smaller than all the other grades, and the 12th grade is a little bigger than all the other ones, and they're all a little bit different. To do this, we're going to use proportions. 120 over 580 is the fraction of the school that is 9th grade, 120 9th graders out of 580 total. And we're going to set that equal to some number of 9th graders in our sample out of 40 total students in our sample. So we have here the population, 120 ninth graders in the population out of 580 in the population. And on the other side, how many ninth graders in our sample out of 40 students in our sample. You always can use a quick little trick to cross multiply and divide. So by cross multiplying here, and I'm actually going to just throw a little x in here so that we have a variable, but you can call it whatever you want. Cross multiply, you get 120 times 40, and that's going to be 4,800. That's equal to, cross multiply the other way, 580x. So we cross multiplied. You want to get x by itself, so what do you do to both sides? You divide it by that 580. So these are going to cancel each other out. You're going to get x by itself. Over here, 4,800 divided by 580. We're going to use our calculator for that. And we get 8.27. And since we're taking a sample of human beings, of people, 8.27 human beings is probably not going to work. So we're going to round this off to the nearest whole number. In this case, we're going to round it down, so we're going to get 8. So we're going to say how many ninth graders? X is going to be equal to 8. So 8 ninth graders in the sample. Once you have those 8 ninth graders, how do you choose them? We're going to go back and use our simple random sample when we do that. So just like before, we put all the names in the hat and randomly picked. This time we're going to only put the ninth graders in a hat and pick out 8 of them. So that's how we're going to choose our 8 ninth graders. Then we repeat the process. We go to our 10th graders. So we keep going to all the other options. So we do the 11th graders and we do the 12th graders. We figure out how many to put in our sample and then randomly pick them.
After completing the table, we can see that there are 8 ninth graders that we are going to consider for the study, 10 10th graders, 9 11th graders, and 13 12th graders. If we are going to add those figures, we get the total sample size required, which is 40. Now let's have cluster sampling. For some cluster sampling, this kind of sampling is somehow similar to stratified. The researcher is now considering to study an entire barangay or entire city. The researcher might as well use cluster sampling for his sampling technique. Here's a video showing cluster sampling.
Suppose you are interested to determine the average scientific skills of grade 6 students in your city. Technically, it would be very difficult for a researcher to obtain a list of all grade 6 students and employ simple random sampling across students in the city. But practically, you may obtain a list of schools in your city and collect data from a subset of this. In our scenario, we may cluster the students according to the school where they attend. Suppose we have School A, School B, School C, Schools D, E, and F. From there, we need to randomly select cluster as our samples. Suppose we randomly picked School A, School F, and School D. But remember, in picking our clusters, we need to consider our desired sample size. From these 3 sample schools, you compute your required sample size using a sample size calculator.
Let us now have sample size. What is sample size? Sample size is the selection of respondents from a population in such a manner that the sample represents the total population as closely as possible. It is said that the larger sample size tends to lead an increased precision in doing a research. For sample size calculation formula, there are some considerations that we must know. There is this confidence level. This confidence level is always expressed in percentage and aligned to the confidence interval. For the margin of error or the confidence interval, it states that no sample will be perfect. So you must decide how much error is to allow. The margin of error describes how close we can reasonably expect a survey result to fall relative to the true population value. Here are the different levels. For a confidence level of 90%, the margin of error is 0.1, and 95% of confidence level, we have a margin of error of 0.05, and for a confidence level of 99%, we have a margin of error of 0.01. And for the sample size computation, we have here the Sloven's formula. Lowercase n is equal to uppercase n divided by quantity 1 plus uppercase n times e raised to 2. Here, small letter n is the desired sample size, uppercase n is the population, and e is the margin of error. Here's an example. Use Sloven's formula to find out what sample of population of 1,000 need to take for a survey on their soda preferences. First, the researcher will consider what confidence level he wants. If, for example, the researcher confidence level is 95%, that gives a 0.05 margin of error. However, if the researcher considers a 98% confidence level, he will then be using a 0.02 margin of error. For step 2, plugging the known data into the formula, Sloven's formula, we will have n is equal to 1,000 divided by quantity 1 plus 1,000 times 0.05. Why 0.05? The researcher is considering a 95% confidence level. And after computation, we have sample size as 285.714286. And since we can't have a fraction for a sample, we have to round off the answer. Here we will have 286 for our sample size. Aside from using Sloven's formula, a researcher can also use or utilize internet applications that offers computation of sample size. What the researcher will do is just input all the necessary data being asked from the website, and after several clicks, the researcher will get the desired sample size from his given population. That is all. Thanks for listening.